So that's pretty much the electronics, sort of a much neater version of that, and that's it on the PCB I'm going to make. It's not very big, it's quite cheap, you can get 5 of those made for $2 plus shipping. So we've got the 2 stepper drivers there and there. There's the Wemos, one of these widgets there. Zip it to scale. Oh, that's upside down. You get the idea. And then there's where the opto isolators connect to voltage regulators. I've broken out all the spare pins to a header because that's handy to have, and 12 volts in there. That's working pretty well. So I've got I built a base because it kept tipping over. It's just 2 bits of plywood nailed together. And so there's the optos mounted there. So when the arm swings, the little flag passes through the beam and interrupts the thing. And so when it's dead on the center there, I get a logical 1 on the console here. 0, 1, 0, 1. Likewise, when this arm is in the middle of that there, then if they're both lined up, then I get 1, 1. Hey! So the idea is it'll start up in some unknown angle, and it'll first home arm 1, so it'll spin around until it sees the rising edge, sees that go to a 1, then it will keep going until it goes to a 0, and then it'll go back to halfway across, and then so it's dead centered on the tab, and then it will do the same thing for this one. Spin it around, fling it one way and then the other way, and once they're both dead center, that's 0, and we can start doing movements that require absolute positioning. Very cool. So on the final device, this opto will be mounted to the inside circumference of the enclosure, like that. And this one will probably be mounted facing up here somewhere. So the slots will be like, my fingers are the slots. And then there'll be a flag sticking down from this arm. So the flag will sort of spin through the opto like that. And yeah, that's more or less where we're at. That rat nest will soon be replaced with a nice little PCB. Really cheap, like $2 to get 5 of them made, plus 3 weeks waiting, plus $20 shipping, Australian dollars. I decided to put in some jumpers to control the microstepping because the DRV8825s that I'm using can go to 32 by microstepping, which might be too much, might not be, don't know, but I decided to make it configurable. I stole the layout of the driver boards on this Roomba 3D printer electronics board. So they've got the headers for the microstepping underneath the driver, which I think is a neat idea. Okay, next up, I've got no excuses, I've just got to do the software. Okay, bye bye.